In this video, we're going to review integration by substitution and just some integration techniques and ideas in addition. So first of all, if you are someone that's having trouble right now seeing how the substitution works, I'm going to try and give you a little bit of idea here on maybe how to begin. The first thing, I guess, we got to pick out what we want u to be. With something with e, I think a pretty safe choice is the exponent, okay, t squared plus 1, in which case the derivative is 2t dt. Now, I would say that if you're having trouble seeing how this works, how this comes together, I would move the stuff that you've substituted to the beginning and use some of the rules from algebra to rewrite, right? The commutative property says multiplication order doesn't matter, so I've just changed the order of multiplication here. Instead of being t times e to the t squared plus 1, I've changed it to be e to the t squared plus 1 multiplied by t. Same thing. But now, if I go back over here, I could divide both sides by 1/2, so I can replace the t squared plus 1 with a u, and I can replace the t dt with a 1/2 du, because that's what t dt is equal to. So my integral becomes e to the u multiplied by 1/2 du. And I would always take these constant multipliers, bring them out front, and then I would say, well, what's the antiderivative of e to the u? It's e to the u, so my answer is 1/2 e to the u plus c, but I should transform this back to be in terms of t, so 1/2 e to the t squared plus 1 plus a constant is my answer. Okay, let's look at this one. Hopefully, you look and you say, well, I guess the first thing I might do is rewrite with a power instead of a root, like that. And I hope you can pick out that u should be x to the 4th plus 5. Okay, so we can replace this with u, and then du, of course the derivative would be 4x cubed dx. Again, if you're having trouble seeing how this is going to work, use that property of being commutative, that we can change the order of multiplication. Okay, so I just switched the order of the two parts. So now I can make this u, and if I go back here and divide both sides by 4, I can replace x cubed dx with a 1/4 du. So I end up, my new integral is u to the 1/2 multiplied by 1/4 du. Bring this out front like always. Okay. We raise the power, so it becomes 3/2. Divide by the new power. So I end up, I'm going to leave the 1/4 out front for now, multiplied by 2/3 u to the 3/2 plus c. Well, 1/4 multiplied by 2/3 is 1/6. I'm going to substitute back in, so x to the 4th plus 5 raised to the 3/2 plus c. And there it is. There's our answer. Okay, let's do another one. So here, the difference is that we have a definite integral, that we actually have some bounds. So again, I'm going to make u equal to the exponent. Okay, so du is equal to 2x dx. Divide. Again, if you need to rewrite the original integral and say I'm bringing everything, I'm going to switch the order of the multiplication. So now you can make this u, and you can make this 1/2 du, so my integral becomes e to the u multiplied by 1/2 du. Bring the 1/2 out front. Now, one thing I want to address before I move on here are the bounds. The bounds here were in terms of x, right? We're saying we're finding the area of this function from x equals 0 to x equals 2. Well, once we've changed and we're not in terms of x anymore, then the bounds don't remain 0 and 2. The bounds change according to our substitution. So the old bound was 0, so we plug that in. 0 squared is 0. So the new lower bound, well, it's the same, but it's 0. The upper bound, okay, it was 2. 2 squared is 4, so the new upper bound in terms of u is 4. Okay, so the antiderivative of e to the u is e to the u. So I have 1/2 e to the u. And of course, a integral we then evaluate at 4 and 0. So I'd have 1/2 e to the 4th minus, now e to the 0 is just 1, so it would just be minus 1/2 like that. And that would be the answer. Now, if you went back, let's say right here, instead of evaluating, you went back and said, no, I want to write it in terms of x. So I want to have e to the x squared. Well, if you do that, you need to go back to the bounds in terms of x, so 2 and 0. But look at what happens. We plug in 2, we plug in 0, and of course we get the same thing. So either way, but if you're going to leave it in terms of u, you have to rewrite the bounds. If you're going to go back to x, you can go back to the original bounds. Here I just wanted to do a quick review of some integrals. I don't want people to always think of substitution. Of course, we've got other rules. So this first one, the antiderivative of cosine is sine. Antiderivative of 2x is x squared plus c. Antiderivative of 2 over x is 2 natural log x plus, raise the power and divide, so 4/3 x cubed plus c. A definite integral, the first thing we do is find the antiderivative, and then we evaluate at the endpoints. So 2 times 3 squared is 18, 2 times 0 squared is 0, and we find the difference. Here the antiderivative would be e to the x plus 3x. Evaluating at 1 and negative 1, we would get e to the first, so e plus 3. If we plugged in negative 1, we get e to the negative first minus 3. And we could combine some like terms here. Of course, we just have e. E to the negative first is 1 over e. And then we have 3 minus negative 3, so plus 6. So this is our answer. We could type that in, but that's it exactly. And then this one, we have 3 natural log of x plus x squared, evaluated at 6 and 4. So if I plug in 6, I get 3 natural log 6 plus 36. If I plug in 4, I get 3 natural log 4 plus 16. To combine some like terms, of course, 36 minus 16 is 20. Using some log rules, I could make this 6 cubed. Like that. I can make this 4 cubed. We're subtracting logs. That means we divide, so we'd have the natural log of 6 cubed over 4 cubed. We could actually figure out what that is. But you could do some simplifying with your pre-calc rules. Okay. Now, again, I just want to remind you of some of these ideas, of antiderivatives and kind of putting these things together. Let's do a couple more substitutions, and then this video will be done. All right, this first one, I'm going to start by rewriting. Okay, I'm going to rewrite this as the natural log of x multiplied by 1 over x dx. Make sure you see that those things are the same. The natural log of x times 1 over x is natural log of x over x. I'm going to make u the natural log. And the reason I'm doing that is because the derivative of natural log is 1 over x dx. So I can take out this whole thing with just a du. So my integral becomes u du. And that's it. Well, u, we raise the power and divide, it becomes 1/2 u squared plus a constant. So plug back in. Like that. All right, next. Let's make u cosine. Okay, so this will be u. So the derivative would be negative sine. Well, I don't have a negative sign, I have a positive, but I can change the sign on the du. So now I can replace this with a negative du. So my integral becomes u multiplied by negative du, which I'd bring the negative out front just like a constant. So I just have negative integral of u du. Well, we already did this one, right? It's negative 1/2 u squared plus c. Substitute back in. So I'd have the cosine squared of x plus c, like that. You also could write this with parentheses. You know, you could have the negative 1/2, put cosine x in parentheses, and then put squared. That is the same thing. Okay. Now, if on this one you're wondering why couldn't I have made u sine and then du would be cosine, you absolutely could have. You would have gotten a slightly different looking derivative, but they would have been equivalent. Okay, so, or I'm sorry, antiderivative, but they would have been equivalent. So you absolutely could do that. One more. For this one, hopefully you remember that u, we really should pick to be the denominator. Okay, this should be u right here. Again, if it helps you to rewrite it, you could start by saying, well, I like to put the u stuff first and multiply that by 4x minus 5. So then u and then du, the derivative, so again, I can take that whole thing out with a du. So my integral becomes just 1 divided by u du. Well, the antiderivative of 1 over u is natural log. So I can go back and I can have the natural log of 2x squared minus 5x plus 2 plus c. Now, I put the absolute value around here just because you can't take the natural log of a negative number. It's not something to worry about as you first learn this, but it's just kind of a nod to the domain of natural log.